a little bit thoroughly. So what I have here is a couple examples, some drawings. Let's see if I can get these both in here. Alright, so let's cover the NPN first. NPN is the transistor that normally is found in just about any electronic. You open up the fridge, the light turns on. Okay? So it's off until something happens and then it turns on. So we call that an NPN is a normally off transistor. Okay? So this positive, like it wants to go boom, 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 but it can't because it needs to have something. It needs to have a current at this base. Some kind of current, some kind of amperage has to be at this base. And once it has an amperage, then it can go like that. So in this case, same thing. So it wants to go boom, 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 but it can't. Okay? Until there's some amperage. So in this case, we have the positive, and it's going to, when you hook the switch, the positive is going to go plus, 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 plus. And it's going to, the current's going to go into the base, and then this energy can go this way, right into the LED. And because there's this, it protects the LED, because that way it could be like from 100 to 1000K. So that's how the NPN works. Again, we're going to have to do that a few times in order for that to be apparent. Okay, so what about the PNP? How does that work? Okay, in this case, the energy, so we'll do the little ground again. Positive likes to go to the ground. So in this case, it wants to go this way. In this case, it's going this way already. Boom, 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 boom. It's already going. This whole thing is just on all the time. And we have a current at the base already. Okay. In order to turn the faucet of these off, we have to apply no current to the base. Okay. So how do we do that? With a resistor. Okay. And normally a higher resistor value than is the current. So sometimes it'll be like a 10 ohm to turn the current on, and 1000K to turn it off, because we know that would definitely turn it off. Okay, so let's take a look at that here. Alright. In this case, this is upside down to make it so that I didn't have to flip this. So in this case, it's going to go boom, 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 all the way around. It's doing this automatically, and then it's going up, and then it's going right into the LED, and the LED is lit. Okay? And that's because of this one right here. This one is keeping this thing alive. Okay? A 10 ohm resistor is making it so there is no current at the base, because no current equals a negative. Alright, well fine. I'll just flick this button, and then now instead of negatives, positives are going in this direction at the base. And now this shuts this off, so the light was on and now it shuts off because this causes a positive charge to happen at the base. Current flows into the base. So the PNP is a little bit harder to hook up because we have to have this hooked up to it, and then this turns it off. So it has to have some kind of no current, some kind of way to ground it so no current can get to it. So what I've done is I've designed these two circuits, and we're going to build both of them side by side on a breadboard, the NPN and the PNP, and we're going to look at what they do. So you're going to need, we're just going to make this a lot easier, 1, 2, 3, 4 1000K ohm resistors, one 10 ohm resistor. We're going to need an NPN, a PNP, and 2 different color LEDs. So go get all that stuff and meet me back here. Alright, so here's our schematic, the final one, and here's our breadboard, and I did cut some of these wires. See them? They're going to make it a little easier to read for you. I will put some links below where you can get these wires. Basically, you have to make them out of 22 gauge wire, but they're really nice. So this is how I always did it. It wasn't until these things came out and they came in your pack that I started using them, but really I always use these. Okay, so you're going to need 2 switches because there's one for the NPN and one for the PNP. And we're going to start with the PNP. Alright, so first thing we're going to do is we're going to identify our transistor. And we're going to notice that is E up, so emitter up. So E, B, C. Okay, that means I'm going to stick this inside my breadboard so that it's E up. Just like that. So E is this side, that pin. Okay, so then we're going to look at the LED. The E is connected to the positive side of the LED. So we're going to do that. So that's what that looks like. These 2 E's. The E and the LED positive is on 15. Think of it that way. Okay, so then it's going to need 1000K ohm resistor hooked up to the negative. So if you look here, here's 1000K and it's hooked up to the negative. Boom. Alright, then what is it collecting? Well, it's collecting, in this case, a positive charge. Boom, here's the collector. It's hooked up to the positive charge. See how much cleaner that is with those wires? Okay, then we hook this wire to the switch. So this is going to be the base. The middle pin of the transistor hooks up to right there, this leg of the switch. Okay, so now I got a 10K, no, yeah, 1000K resistor, okay? And that is before the switch. See right here? Here's the switch. The switch is open on this side, but it's hooked up to a 1000 ohm resistor hooked up to the negative. So that is my no charge. When no charge is present, it's normally on. Okay. So what happens if we introduce a charge to it? Well, that's where the other side of the switch comes in. Okay, so the other side of the switch is going to be positive. And this is a finicky little circuit. Oh, yeah. That was definitely not the 10. Okay, so this is the 1000K resistor. So the 1000K resistor hooks up to ground. I had it backwards because this stripe is gone on it. Weird. That's an orange stripe, but it's gone. Okay, so no, it's normally on. It was getting hot because it was the 10 ohm resistor couldn't handle it. Alright, sweet. And then the 10 ohm resistor, it's hooked up to the positive. So that's going to be introduced to charge. So right now, this is a no charge. It's 1000K. It's hooked up directly to this, bypassing the switch altogether. And then when I press this button, it's going to introduce a charge. So this one's hooked to the negative, this one's hooked to the positive. And boom. Okay. If you at all feel that any of these stuff is warm, it's because you don't have it hooked up right. So neat. Okay, so that was easy, except for the resistor with no color. And now we're going to make the NPN.